Welcome to lesson 6.2 in your Go Math. We're talking about size of equal groups today, meaning that all of your numbers are going to fit into a group in perfect order with none of them left outside of the order. Your essential question today is how can you model a division problem to find out how many are in each group? So kind of piggybacking off of 6.1 where we talked about acting them out, and a reference to your Common Core standard again. If we look at our chapter review vocabulary for this one, we talked about divide is to separate into equal groups. Your dividend is the number to be divided in a division group. Your divisor is the number that divides the dividend. There's those two ones again. Hopefully you got them in your math journal by now. Inverse operations is your opposite operations, adding and subtracting, multiplying and dividing. Quotient is the number that results from the division problem. So let's see if I line this up so it didn't go through my word. Looking for it's your answer. Okay. And related fact is a set of related multiplication and division facts like 3 times 4 equals 12, 12 divided by 4 equals 3, having those same numbers on there. Your main vocabulary word for today is divide. Okay, so dividing things into equal groups. Okay. And starting with your problem of the day. So you should have your math journal and the date. And we are doing lesson 6.2. Start with problem of the day. Copy this down. Christopher scored 889 points in a video game. What is Christopher's score rounded to the nearest 100? So you have 889, and you're rounding it to the nearest 100. So thinking, is 889 closer to 800, or is it closer to 900? Okay. Go ahead and fill that in, and don't forget, what is Christopher's score rounded to the nearest 100? Your complete answer is Christopher's score rounded to the nearest 100 is, and then decide which one of those it is so that it's labeled. Jumping into our lesson, you should be on page 213 and looking at our problem solving again. Remember, when we read through a problem solving story, we underline our important facts and we circle either those or we circle the questions they're asking us, whichever helps you keep track of what you're looking for easier. So Hector has 12 rocks from Onondaga Cave State Park. He puts an equal number of his rocks in each of 3 boxes. How many rocks are in each box? So he has 12 rocks. He puts an equal number of them into 3 boxes. And your question, how many rocks are in each box? When you multiply, you put equal groups together. When you divide, you separate equal groups. So there's your vocabulary word, divide, separate into equal groups. Okay, looking at our blue box, what is it that they want us to find? Is all we have to look for is our question word and what we circled. They want us to find out how many rocks in each box. And up that said circle the numbers we need to use, we underlined, so that's fine too. It's giving us a hint here that it wants us to put them into equal numbers into boxes, which tells us that we're going to divide because we're separating them into equal groups. If you choose to use the counters that are at your computer, you may do that. Or you may draw them out, which looks like what they're doing in step 2 here, which is the way that I used to solve them. So if you are using your counters, you need to count out 12 counters, please, and put them on a surface around you so that you can use those. How I'm going to do it is the way that they do it in step 2, drawing 3 circles on your math board, so you can use your math board or your whiteboard, and always the white space on your page. The reason it says to draw 3 circles is because there are 3 boxes. So each one of these is going to represent a box that they are using. Okay. Place one counter at a time into each circle until all 12 counters are used. Draw the rest of the counters to show your work. So we're counting out the 12 rocks into 3 sections. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You notice that we have an equal group, which is what it asked us to do. So there are blank counters in each group. Looking at them quickly, you can see that there are 4 counters in each group. So there are 4 rocks in each box. Using this beautiful white space over here that they gave us, I'm going to check my answer. And knowing that 3 groups of 4 equals, what is 3 times 4? We know that 3 times 4 is 12. So there's our missing number, our variable. We had 3 groups of something, so there's our variable, was going to equal our 12. So I've checked my work knowing that 3 times 4 equals 12. I know that this answer is correct. That was an easy problem to start our day off. So let's move on to our next page. You should be on page 214. Says Madison has 15 rocks. She puts an equal number of rocks in each box. How many rocks are in each box? I cut off the problem when I took a picture of this page, so we'll have to use your book. She has 15 rocks. I'm just going to write that because normally I would underline it, being an important part of our problem. She has 5 boxes. How many rocks are in each box? So the question that we're looking for is how many rocks are in each box. So it wants us to, step 1, draw 5 squares to show the 5 boxes. Okay, now draw 1 counter in each square to show the rocks. Continue drawing 1 counter at a time until all 15 counters are shown. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Keep going until you get to 15. Okay, each box. 3, 6, 9, 12, 15. So I have how many? There are blank counters in each box. Each box has 3 counters. So there are 3 rocks in each box. Okay. I can check this by having, I had 5 groups of, we were trying to find this, to equal 15. And I know that 5 times, here's our number in each box, 3 equals, if I count by 5 3 times, 5, 10, 15, I know that my answer makes sense. How many counters did you draw? How many did we totally draw out in each one of these to show how many rocks we had? We drew 15 counters. How many equal groups did you make? We made the groups that they told us. We made 5 groups. And how many counters were in each group? Was 3. So again, checking it here, that you could do that. Okay. If we look at the math talk, another way to arrange the 15 counters to make equal groups, we know that if we switch our numbers around using the commutative property, that we could have also made 3 groups of 5. 1, 2, 3, 4, 5. And that 3 times 5 would also give us 15, so we could have arranged it that way, using the commutative property, switching those numbers around where they are at. I think that this is going pretty good, so let's move on to our next one. You're going to draw a picture to show the numbers of counters in each group. Again, I cut off the story problem, sorry about that. So you're looking at page 215. John has 8 counters. Since I cut mine off, I'm going to write them in there. You're going to underline that part. And he makes 4 equal groups. So again, you're going to underline where it says 4 equal groups. Draw a picture to show the number of counters in each group. So we wants to know each group. We have 4 of them, so we need to draw 4 groups. And we are going to count out our total number of 8 counters. 1, 2, 3, 4, 5, 6, 7, 8. And it's really all that they asked us to do in that problem. It didn't ask us to do any than that. Draw a picture to show the number of counters in each group. 8 counters, 4 groups. This tells us that 4 times 2 equals 8, which is the same as 2 times 4 equals 8. So by using our new vocabulary of knowing that the opposites and we can use the common factors, we can also know that 8 divided by 4 is going to equal 2, and 8 divided by 2 equals 4, using those same numbers. Looking at the next one, numbers 2, 3, and 4. Use counters or draw a quick picture on your math board. Excuse me, make equal groups and complete the table. Okay? So let's start at number 2 here. And it looks like we have just a little bit of white space over here that you can use for this. Okay? So we need to look at our table. Our table says how many counters, numbers of equal groups, and the number in each group. So for the first one, number of equal groups is 2. So I'm going to draw 2 groups. And I need to divide my 10 counters into those 2 groups. So count through until you have your 10 counters. And then it wants to know numbers in each group. So how many are in this group and how many are in this group? Making sure that you actually have the same number. You really should count both of these to make sure that they are equal, that you didn't get distracted or accidentally count an extra one in another group. I have 5 I bundled and 5 I bundled. So 10 counters divided into 2 groups gives me 5 counters in each group. Okay. Your next one, 6 groups, and you have 24 counters. So 1, 2, 3, 4, 5, 6, and I'm going to count out 24. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Keep going. Count each one of these. That one was ugly. I should have probably erased that if I would have been using a pencil. I have 6 groups, and I divided out the 24 counters, and there are 4 in each one. Moving on to number 4. How many groups do I need? I need 4 groups. This is going to be the part, guys, where you're going to really have to work within your workspace to make it clean and neat. You had space up here that I just did a division problem in you could have used. You have space on both sides, but you want to make sure that you're writing nice and that you're keeping it all organized and neat so that you can use it to go back to. Okay, so I have my 4 groups, and now I need to count out how many counters. Go ahead and do that. 2, 3, 4. So how many are in each group? Count these real fast, just to make sure I have the right numbers. And 3. Okay. To check these, we're going to really work on that. I can do multiplication. 2 times 5 equals 10. 6 times 4 equals 24. 4 times 3 equals 12. I know that those are right now. Okay? I want you drawing these pictures for this lesson. That was one of their main focuses for this lesson, just so that we understand how the division process works. Next one is on your own. You're doing the exact same thing that you did up above. Okay? You have total numbers of counters, numbers of groups you need to make, and then going back and actually counting how many are in each one of those groups to fill in your numbers of your group. Okay? You're not going to do that right now. You are going to move on to page 216, and we are going to look at this problem. Okay, use the table for 10 and 11. So let's spend some time first looking at our table, which is a skill I hope that you're using on your own now when you're using tables because we've worked on them a lot. Our table title is photos. This is the name column, and this is the number of photos. So it looks like Madison has 28 photos, Joe has 25, and Ella has 15. Again, yours isn't going to be as blurry as mine is. Okay, so looking at number 10, Madison puts all of her photos in a photo album. She puts an equal number of photos in each of the 4 pages of her albums. How many photos are on each page? Okay, we've read the problem. Now we're going to go back and look at our clues. Madison puts all of her photos in a photo album. She puts an equal number, so that tells me we're going to be dividing, of photos on each of 4 pages. How many photos are on each page? Okay, so Madison has 28. So we have 4 pages. And we're going to count out the 28. So how many photos are on each page? Go ahead and fill that in, and do not forget to label it as photos. Number 11. Again, keeping my workspace nice. Number 11. Joe and Ella combine their photos. Then they put an equal number on each page of an 8-page album. How many photos are on each page? This one is asking me to do 2 things. First, I need to combine their photos. So Joe has 25 photos, and Ella has 15 photos. I'm going to combine them by adding them together. So they have 40 photos in all. Okay, that's my first part of my information. Then they put an equal number, so now I know I need to divide, on 8 pages of their photo album. So how many groups am I going to make? I'm going to make 8. And then you're going to count out your 40. Okay? So go ahead and do that. And don't forget to label it. Number 12 and 13, I think you can do. Rebecca's family found 30 sand dollars. Explain how to share the sand dollars equally among the 6 people in her family. Okay, so you're going to split the 30 by 6. And then on the bottom, Xana has 9 rocks from a trip. She puts an equal number of rocks in each of 3 bags. How many rocks are in each bag? So you have 9 rocks, 3 bags. Okay, so you have 9 divided by 3. Okay. Go on to the end. At the very beginning of the lesson, your essential question was, how can you model a division problem to find out how many in each group? So go ahead and grab your math journal. This was lesson 6.2. And put the date. Copy your essential question here. How can you model a division problem to find out how many in each group? When they're talking about modeling, they're talking about acting out again, where you're drawing your groups. So figure out how to put that in a sentence, giving me a little example here. And then on the bottom of that page, your math journal. Describe how to divide cookies equally between 2 of your friends. Okay? So how are you going to divide a bunch of cookies between 2 of your friends? It doesn't tell you how many. It tells you you're going to divide it by 2 friends. Okay? So how are you going to have 2 friends and divide cookies? You're going to have to add in your own amount of cookies so that we can make a math problem out of it. Okay? Go ahead and go back and finish the on your own page, which was page 215, and finish working out and labeling the numbers from the problems from page 216, and then do your math journal for today, please. Remember, if you don't understand something, you can always go back and rewatch and pause it at any time to fill in your book and ask questions. We will correct this together.